Give a counterexample for the given conclusion. All right, so now we need a counterexample. Don't forget, a counterexample is going to prove it wrong. So we're trying to prove this statement wrong. All right, so given that BD intersects BC at point B, we need to draw a different conclusion, or disprove the conclusion that the rays intersect to make angle DBC. So if I draw, say for example, this ray, that's B and that's D. And then it says that BC intersects at point B, then this is how we would normally draw that. But we're trying to prove that it's false. So what's another way we can draw that? We can still draw ray B, C, but we can make them overlapping rays. So now it's not an angle, it's just a ray. A ray on top of another ray is still a ray. So there you go. All right, and number 23. So we start with given. Remember, we always start with given. All right, the second step, and we're not counting, let me highlight them. So we're only counting the actual steps, not the in-between parts. So the highlighted parts are the actual steps that we're counting, or that we're writing about. All right, so how do we get from the first step to the second step that I highlighted? So let me count these: 1, 2, 3, 4, and 5. So these are all the different steps. So how do we get from step 1 to step 2? We subtracted. All right, how do we get from step 2 to step 3? Well, we added plus 24, so that's addition. How do we get from step 3 to step 4? We divided, so that's division. And how do we get from step 4 to step 5? We reflected, or used the reflexive property. Okay, so there you go. Next problem. What's the hypothesis of the given conditional statement from number 1? That's supposed to say number 17. So on your copy, go ahead and change that to number 17. So if you look back up here at number 17, the hypothesis is going to be if two angles are a linear pair. So don't forget the hypothesis is P, or the first part. So what was it again? If two angles are not a linear pair, okay. Sorry about that. If two angles are a linear pair. Okay, so that would be the hypothesis because that was part P. And then underneath that it says, what is the conclusion of the given statement? So if two angles are a linear pair, then they are adjacent. Okay, moving right along. All right, number 21, use the law of syllogism to make a logical conclusion. So just like before, the first part says if 3 points are non-collinear, the second part says then they determine a plane. Then it repeats that if 3 points determine a plane, then they are coplanar. So I know it doesn't look exactly the same wording-wise, but it means the same thing. Then they determine a plane. When they say they're referring to the 3 points. You know what I'm saying? So it says if 3 points. So it could have still said they. It would still mean the same thing. But regardless, cross it out because it was repeated. And then we're only going to keep the first part and the very, very last part. So let's write that down. If 3 points are non-collinear, then they are coplanar. Okay. Number 22, use the law of detachment to make a logical conclusion. All right, so detachment means that we're not crossing anything out. We're just going to apply what the first statement says to the second statement. If a triangle has a right angle, then the other two are acute. Angle C is a right angle in triangle ABC. So that means in triangle ABC, there's a right angle. So let's draw a right triangle. Not like that. Okay. And then we are going to label the right angle C. All right, so since C is here, it doesn't tell us where A and B are supposed to be, so we can just make an educated guess. All right, so the conclusion that we can make based on this, or about triangle ABC, is that angle A and angle B are acute. Okay, because we're talking about this, and that basically confirms this. So this is the part that we're going to basically apply to triangle ABC. So the other two angles are acute, and the other two angles are A and B. All right, next problem, 24. Write the following statement as a biconditional. Okay, so biconditional, don't forget it says if and only if in the middle. So an angle, don't write if, an angle is a straight angle, or is straight, if and only if it measures 180 degrees. So an angle is a straight angle if and only if, don't forget that, if and only if it measures 180 degrees. So don't worry about the if, don't worry about the then. You just put if and only if between P and Q. Next, array is an angle bisector. Array that is an angle bisector cuts an angle in half. Okay. Supposed to say and. Okay, so the conditional, let's write it. If a ray is an angle bisector, then it cuts an angle in half. All right, so we just took that. That's going to be P. That's going to be Q. Let me keep that same energy I've been using and highlight P. So that is part P, the hypothesis. That is part Q, the conclusion. All right, is this true? If a ray is an angle bisector, then it cuts an angle in half. That is true. That's the definition of bisect. All right, converse. So this one, and don't forget this was P, then Q. This one is Q, then P. Okay. If a ray cuts an angle in half, then it is an angle bisector. Okay, so I know that I put the word ray first. That's okay, because the angle bisector part is really what P is. So that's the part that I needed to switch with the cut in half part. Okay, now for inverse, we have not P, not Q. If a ray is not an angle bisector, then it does not cut an angle in half. So if a ray is not an angle bisector, then it does not cut an angle in half. Contrapositive, don't forget that's going to be not Q, not P. So it switches spots and it becomes not. So if a ray does not cut an angle in half, then it is not an angle bisector. All right, last but not least, the biconditional. So, actually, let's figure out true and false. So the converse. If a ray cuts an angle in half, then it's an angle bisector. That is true. Inverse. If the converse is true, the inverse should also be true. So if a ray is not an angle bisector, then it doesn't cut an angle in half. That's true. If the conditional is true, the contrapositive should be true. So don't forget, these two should be the same truth value, and these two should have the same truth value. All right, so if a ray does not cut an angle in half, then it's not an angle bisector is also true. So the biconditional is possible. So for the biconditional, you do not start with the word if. So a ray is an angle bisector if and only if it cuts an angle in half.